Okay, so we're back. After we've hooked everything up, we've walked around, we've made sure that all the lights are on. Now we're going to do what's called the critical three. So the first of the critical three is checking your primary amperage. And again, your primary amperage, when I say primary and secondary, the difference is primary is always going to be your 120 volt power, and your secondary is going to be your low voltage side, your 12 volt side, or in some cases even some 24 volt stuff. Looking at the transformer, again, it's a 200 watt transformer. My maximum amperage I can put on this transformer is 1.66 amps. So if I exceed that 1.66 amps, I've got to make a change. I've got to go out there and reduce the wattage of the lamps. I got to reduce the fixtures, whatever I have to do. But either way, no matter what, I have to be under 1.66 amps. So I'm going to take my amp probe to check my primary amps, set on my amp setting. I'm going to let this zero out. And then if you notice our primary power connection right here, we have a fused outlet. This is the power cord that actually goes to the transformer itself. So when you plug it in, this is separate because when you check amperage, you have to check either the hot or the common side. So if I were to check both, you're going to see that it's going to eventually zero out and say nothing at all. But if I check just one or the other, so now I've just connected to one, I'm at 0.29 amps. And then if I check the other one, it'd do the same thing. So 0.29 amps compared to my 1.66 amps, I'm well within range, so I'm way under power on this transformer, which is perfect. So that's primary amps. The second of the critical three is secondary amps. So now primary is the 120 volt side, secondary the low voltage side, and so what I'm going to check for is I'm going to make sure that none of my home runs are going to be over the maximum allowable amps for the size wire they are. These happen to be 12 gauge wires, so maximum amperage is 20 amps. Now, generally the National Electric Code is going to tell you that you can't exceed 80% capacity on these wires. So 80% of 20 is 16 amps. So my maximum amperage I want to check for is nothing over 16 amps. So again, leave it on the amperage setting and you're just going to check one of the home runs. I'm at 0.20 amps. So, and you see it's still dropping, zeroing in right now. So 0.19 amps, way under my 16 amp max. And then I'm going to check the second home run. And I'm at 1.56 amps, so again, way under my 16 amps. So looking at this, obviously I could have probably put all these fixtures on one home run, but again, one transformer home run wire is going to the backyard, one's going to the front yard, so we just have it separated out for future expansion. So now let's go take a look at the third of the critical three, which is voltage at your point of connection. Okay, so now that we've hooked the transformer up, we're going to check the power supply over here. Again, these are Flex Series LEDs that we're using, so the voltage range is between 10 and 15 volts, and it's good practice to be right at 12 volts. So let's check and see what we have. So I have 12.2 volts here at my point of connection. If I go up a volt, it'll be at 13. If I go down a volt, it'll be at 11.2. So I'm going to say 12.2 is just fine. At this point now, what I'm going to do is I'm going to use my grease caps, spin these things on here. That gives it a nice seal. Take my hub. And until I bury the wire, I'm just going to let those hang out just like that. On to the next. Okay, so now that I've gone and checked the voltage at our hubs, one's at 12 volts, the other's at 12.17, and I know my voltage range for a Flex Series LED lamp is between 10 and 15 volts. So, common practice is to try to get it right at 12 volts, and that's what we've done. Now that I know the voltage is correct, I'm going to unplug the transformer, disconnect power. I'm going to take out my two hot leads, because now I know that I don't need to move them around at all anymore. I'm going to go ahead and dip those into the grease. Put a nice little coating on there. Put it up into the transformer. And the grease is to prevent any oxidation happening to the wire. In the case if you have moisture in the air, especially coastal locations, you get a lot of that salt in the air, and this is going to prevent anything from happening to this wire. If you notice, I'm not I'm not being afraid of putting a lot of grease in there. So got quite a bit of grease. If anything, it just helps things out. Now the transformer is ready to go. Next is going to be programming a Light Logic LPCU A module to this transformer. So stay tuned, and that's what's next.